And the next speaker, I probably pronounce this, is Xiaoxue Bi. Is he around? Or she? So, yeah, sorry. Large language model, eh? Yeah. This one, eh?
Oh, yeah.
Okay. Okay, and you can hold the mic close, or do you want to speak on this mic?
Yeah.
With this one? Okay.
Good afternoon. My name is Xiaoxue Bi. Thank you for giving me the opportunities to present our work. Today, I will give a talk about large language models-based AI agent as an intelligent assistant system for experimental data acquisition at fourth-generation sacral radiation light source. My talk will start from the project background and followed by the technical approach for the project applications and challenges. Well, for the project background, due to the diverse data acquisition mode and a complex online analysis method used at various beamlines of the sacral radiation light source, beamlines users are often required to get acquainted with interface functionality and the workflow of the data acquisition software before they start the experiment. We think such process highly rely on the guidance from the beamline staff and users. They should read the instruction document on site, which are very time-consuming. Therefore, we propose an AI agent as intelligent system of the data acquisition software for the sacral radiation light source beamlines. The system utilized the large language model as a command help to parse the beamline user's linguistic description of the experimental process, assisting user to customize experimental process and parameter setting through its knowledge base and the comprehension capabilities. The system interactively exchanges information and data with the member by the agent. Member is the data acquisition software framework for fourth-generation sacral radiation source to facilitate experimental process control in an automated and intelligent manner that significantly lower the learning curve of the data acquisition software. The system also provides an intelligent question and
No, it doesn't. It's a problem. Is there anything we can do with that? No. I think we have to use this mic. Sorry. Yeah. And just hold it close. Yeah.
The interface question and answer sections, the required material, structures, and physical information can be obtained from the pre-trained large language model at the self-built knowledge bases, and the system treats the query information as a metadata and save it together with experimental data into the field. For the technical approach, according to the world's first AI dialogue system classification definition, invented by Professor Huangmin Li from Tsinghua University and joint developed with a multi-researchers institution, AI dialogue systems are classified into 6 levels from 0 to 5. Each level represents the capability of the AI dialogue system in various aspects, including automatic dialogue capabilities, dialogue qualities, then adaptabilities, degree of the personification, learning ability, and so on. And the GPT-4 is currently considered to be at level 2. Therefore, our technical approach is as follows. To facilitate development, we use open source software for secondary development, such as RagFlow AutoGen. For the intelligent question answer and system, we first established a specialized domain local knowledge base. Next, we performed data augmentation, cleaning, and enhancement. For the security and privacy consideration, we developed the local model. And finally, we use prompt engineering to improve the accuracy of the model response. And for the AI agent system, we first attempt to establish a non-AI agent model to familiar the entire process of the control experiment based on the agent. We then gradually replace the agent with a large language model to develop the virtual control mechanism and set up a safety lock mechanism to enhance environmental control. After that, we will validate the AI agent in the virtual environment and then transfer it to the real production environment to take over the environmental control. For the intelligent question and answer system, in specialized domain question and answer system, generally, large language model may perform poorly. So the RAG technology can specialize, improve the accuracy of large language model response for the specialized knowledge. RAG technology transforms the private data into semantic vector using embedding model and stored it in the vector database. When a user queries the large language model, the questions are encountered into the query vector by the embedding model. The query vector is then used to retrieve the knowledge from the database. Based on the retrieved knowledge, the most relevant answer is selected and input into the large language model. The large language model utilized its powerful text integration and summarization capability to produce results and feedback to the users. It reduces the probability of the large language model generating hallucination, improves the accuracy of the specialized knowledge answer. And for the AI agent system, AI agent can automatically plan response to question and dynamically call the register tool for user. The functionality of those tools can be customized, significantly reducing the code and the operation complex. So we should develop the customer's beamline, experiment control, and physical analysis tools. Conjunction with the intelligence question and answer system, it can enable to automation for the tasks such as finding the user menus, configuration, experiment, and setting up the process. We are now have a look at the current progress of the application part. This is a new generation of the secretary radiation control of the data acquisition software framework, ML. ML has already been developed at BSRF's 4W1B, 3W1, and 1W1A beamlines, serving a large number of users for the data acquisition. It will implement across 14 beamlines of the next generation secretary radiation source to support even more experimental users. The AI agent is used as an intelligent tool for the beamline, employing a large language model to analyze the user need and automatically generate executable command and inject it in the ML backend for control experiment. The intelligent question and answer system will interact with the user from the front end and guiding them in using the member data acquisition software and searching the knowledge during the experiments, which can be stored as the metadata. This is an experimental control and data acquisition software developed from the HAPS BE beamlines based on the member software framework. The beamline can achieve the non-data acquisition mode, tomography, single count, continuous focus series, background averaging, mosaic, and tomography with background, as well as various spectral CT acquisition methods, including 2D, 3D step scan, and 3D flat scan, and so on. In addition, the software also provides some complex functions such as energy calibration. Currently, a non-AI agent control mechanism has been developed in the beamline. It can generate commands that meet control requirements based on the user need through text matching, and automatically inject those commands into the member backend for controlling the data acquisition. This video demonstrates the user performed a single data acquisition and the monitor movement function in software using the linguist. However, the level of the integration cannot meet users' complex demand description. Therefore, we are attempting to integrate large language model to the system. To facilitate the development work, we are attempting secondary developed on open source software such as Ragflow AutoGen, Long-Chain Chat, and another excellent open source tool. The image shows the user interface out of AutoGen. Currently, the AI agent is in the development stage due to the large language model has hallucination compared to the text matching. We are trying to implement it in the virtual beamline of the member. Another exploration focuses on the question and answer system, and we are currently considering implementing the open source software Long-Chain Chat. The domain include user question to assist the user in their experiments, such as what is member or asking about local knowledge-based processes like how to automate funding simple. Given the importance of the data security, we are using the locally deployed open source model Qianwen. We are considering deployed the question and answer system on another computer outside the member industrial control computer, serving as an endpoint for the member data worker. When interact with the member industry control computer is needed, it will send the JSON information to the member front end to get the user in their experiment. There are still some challenges during the experiment process of the project. The challenge of the large language model of the intelligent question and answer answering system. The first is limit of the local model. The intelligence of the developed local model is limited. They may have difficult accurately answer over complex questions, and hallucinations still occur. However, the issue is unavoidable due to concern about the safety and privacy. Second is the capabilities of the embedding model. The encoding capabilities of the embedding model affect vector retrieval. Third is the document construction in local knowledge bases. The form of the domain-specific technology affect vector retrieval and model understanding. Therefore, further exploration is needed to optimize in this aspect. And the challenge of the AI agent system is an intelligent problem with the local development model. Low performance may lead to failure in properly invoking tool or understanding instructions. Second is the prompt engineering. The capability of the agent are related to the prompt. A well-designed prompt template can enhance the model's accuracy. Finally, the inaccurate instruction recognized and execution. This may be related to the model's performance and the design of the reasoning chain prompt. It is also crucial to ensure security controls, as any mistakes in control could lead to experiment failure. That's all of my talk. Thank you for your attention.
Thank you. We have time for one pressing question. Is there any volunteer to use the system on a beamline? I think it's a way that's coming, yeah. So it's very interesting. But I was more interested. I'm wondering if do you see the potential more in helping users to find out what happened on the beamline, or to actually run the experiment? Is it more for post-analysis or for actually controlling the beamline? We can take the discussion offline, yeah. I don't know if you have any experience with that, no?
So I'm sorry. Could you repeat your question?
If you think this is more for offline analysis or for actually controlling, running the experiment?
它是在线还是离线？更多的是在线还是离线的一个过程。So I think it's more. I'm not sure. I think it's more of because it's gonna be integrated with the online acquisition system member. So it's more of the online system rather than the offline. Okay. Yeah.
Okay. Thanks once again. Thank you.